Good evening from the woods of Maine, or should I say late afternoon? Feels like evening. Days are definitely getting shorter. It's October 6th, and foliage is coming to a peak here, and everything's real beautiful. If you're an alien, you landed here, you'd really wonder what's up. Um, Colors are just really coming out, but anyway. So last I left, we were on the border of the Ordovician period, and the Ordovician period is a time of a lot of tectonic activity in the New England area, especially the New England area. New England up through Nova Scotia to Newfoundland, over to Scotland, Ireland, those areas there. What we have happen is the main event in the Ordovician is going to be the closing of the Taconic Seaway and the first in a series of island arcs that begin to accrete to North America. And the first set to go is an island arc that formed out in the Iapetus Ocean, and essentially it was one piece of oceanic crust going under another piece of oceanic crust, and a subduction zone formed, and eastward, from today's point of view, would be forming eastward, and essentially sucked that or pulled that island arc across the Iapetus Ocean, and it accreted into Laurentia, starting about 480 million years ago. And this event built the Green Mountains of Vermont, the part of Nova Scotia, Quebec, east of the St. Lawrence, up through Newfoundland and Labrador. And of course, at the time, Scotland and parts of the UK were part of this area, and they were also affected by this. So fairly big mountain building event. The trench away from the continent itself, therefore the arc was being pulled over and eventually came into Laurentia and then actually switched polarity. So that's pretty much what went on in the Ordovician time. Here's the Ordovician from the famous Blakey maps right here. You can see the island arc offshore. This is where we would be. The trench is right here. It is going this way, dipping this way. And this whole thing is basically getting pulled over, and it's going to accrete right along this whole border right here. And this is going to fill in this embayment here that of North America and start to fill this in with the Green Mountains. Not a whole lot of action going on over here on the west side of the continent. We have yet to build the southeast. There is somewhat of an interior seaway. There is some epicurrent seas. So sea level is fairly high, on the early Ordovician. Ordovician about 470 million years ago. You can see the arc is now approaching and starting to accrete onto Laurentia. Sea level looks to like it's rising a little bit. Seems like there's a bit more of the Laurentia continental interior flooded a little bit. We have some action going on over here. This is probably what will be pieces of Ganderia, as well as Avalonia is somewhere out here looming in the distance, about to start to make its way across and adhere over here as well. At 450, we have contact here. We have mountain building along the east coast of Laurentia. We have interior sea flooding, sea level is high. We have, again, another series of terrains on their way over, crossing the Iapetus Ocean. Here we have an Andean-style mountain building event. So, Taconic mountains probably pushed 20,000 feet into the air. Very typical of what you might see the Andes of today. A narrow but fairly powerful and tall uh, mountain range. Without a doubt, had some volcanics associated with it. And what's going to happen is before the subduction zone is dipping to the east, but what's going to now happen is once this accretes, it's going to start dipping to the west. The exact mechanics of that are not clear to me. Maybe somebody out there understands them. The arcs are always fascinating, but my guess is that it was pulling everything this way, and if it was dipping and being subducted, it probably just continued, but without any more oceanic crust, really, because you now have an arc. It more or less probably just kept pulling down, and therefore subduction decided to start coming from this way. I don't know, but it is peculiar that this is not an uncommon occurrence. We've seen this happen in other places on the planet as well. So it's not that irregular. Ordovician tectonic and paleogeographical maps here. So we have gone from the Grenville, about 1 billion to about 900 million years ago. During Rodinia broke up. We had a nice passive margin in the late Neoproterozoic into the early Paleozoic, where life thrived. We had an island arc form offshore. It is now being dragged over. This island arc is represented by this guy right here, and is now accreted into North America and has built an Andean-style mountain range. And eventually this subduction right here, this zone, is now going to flip as represented down here. Exactly when that happens is not entirely clear, but we do have lines of evidence from plutonic activity being dated and geochemical analysis to tell us when you have a switch from a ocean subduction zone going under an oceanic plate to what happens when an ocean plate begins to go subduct under a continental plate. So that's sort of your key right there. Very complicated stuff. I'm not going to go into it, but there is a way to tell. And then you have sediments that were scraped right here, accreted on here. So you have sediments on ocean line being compressed, uplifted, and creating a mountain range of Laurentia. And there you have it. The island arc, these are the oceanic sediments, and this is all going to slam and create this guy right here. Nice big mountain range. And if you were to look over here, this kind of gives you an idea of facies that you see. Remember we mentioned that the oceanic crust is higher. I mean, not the oceanic crust, but the ocean sea level is higher than it normally would be relative to sea level stand. So we have continental and flooding. So you have carbonate disposition. This is right on the equator, so you're going to have a lot of warm water. So you're going to get a lot of carbonate. You're going to get sandstones and debris coming off the newly formed mountain ranges, forming beaches. From quartz and what have you. You have a trench right here. You have volcanic sediments being produced and dumped in here from volcanic activity associated with subduction. You got shale being deposited up in the deep water off into the trench. So one thing we notice is this trench, when it finally gets exhumed, later on down the road, when I drive out to western New Hampshire and Vermont, I see tons and tons of shales, and shales are, very fine black shales and dark shales are indicative of deep water sediments, and that's the trench of this guy being filled in. So it's kind of cool when you go out there, you can kind of see it. All right, where are we on the time chart? So yes, Rodinia, Grenville, Rodinia breakup, Iapetus opened. We have the Taconic Seaway that opened. Now the Taconic Seaway has closed, and we are building the Taconic Mountains, and this is the Taconic Orogeny right here at about 480 million years ago to about 440, I believe 460. I get exactly when it's the representation of the time is, but here it's saying to about 460 maybe. Thought it was about 440, but somewhere around 460 maybe. You have the closing of the Taconic Seaway, the mountain building episode, and we are now going to start going into the next cycle, which will be the involvement of offshore island arcs that are being torn off of Amazonia while this is occurring, and then they travel across and slam into Laurentia, and that will be coming up next. This to give you an idea of what's going on in eastern Vermont at the time that this was happening. We have a oceanic crust right here. We have an island arc that formed. The island arc was subducting. The oceanic crust associated with this piece with this arc was subducting this way. The whole thing was getting pulled over. As it got pulled over, everything just got slammed in and thrust up onto here. Subduction will then reverse and start going under here, but that has not occurred yet. We have a little inland sea here, caused from the stretching of the crust as this is dipping. We have a beautiful carbonate shelf left over from the late Neoproterozoic, early Cambrian, and this is going to create all sorts of marbles. And there are a ton of marbles in Vermont. I myself have been out to Proctor, Vermont, and I was in marble heaven. Everywhere you look, marbles. There are marbles in western Connecticut. I know there are marbles in New York, very far eastern New York, as well as other places. But the marbles associated with this are in eastern New York, and most likely marbles up in Quebec, on the eastern part of that as well. So yeah, this is a result of this island arc crunching these beach and reef sediments that went from limestone to marble. The classic cross-section of the Taconic orogeny events. And believe it or not, this is great, but we think it's going to be, as science moves on, everything seems to get a little bit more complicated. So, yes, this was classic, but there's probably a whole lot more to it that went on. But this is, for our intents and purposes, this works great. Cross-section, eastern North America, as it may have looked, you had a carbonate bank, kind of like you'd have off the Great Banks of Australia, or say the Bahamas. You had the continent of Laurentia here, the eastern part of it, which was present day sort of like New York. I put Vermont, but very, very little bit of this is Vermont right here. You have the oceanic crust dipping to the east, dragging this arc over. You're scraping off sediments right here, and this is all going to get crushed over here, as represented here at 543. You have the offshore island arc. It is approaching. It's getting blasted up with volcanic activity as approaches, as it was here as well, but the subducting plate is adding terrain to it. This is beginning to get squeezed and shortened. Thrust faults are beginning to evolve, and the whole thing is getting shortened and then forced up to the west. And then boom, about 440 million years ago, this whole thing happens. I'm sorry, this was 543, 500. This is interesting. Yes, 543, 540. Okay. Sorry about that. Yeah, so 543 is when that all happened. 500 is when everything was getting shortened and the approaching of the volcanic arc. And then at 440, you actually have the whole series is finished. This has now been thrust up into Laurentia. All this material here has been deformed, and a series of thrust faults has pushed this back. This has been thrust up onto the continental crust. And then the oceanic crust is continuing to push. What they're really missing here is that this is actually this subduction zone is breaking off and slowing down, and then now this will start to continue and go off down this way. So that's the simplified version of the Taconic orogeny, and these are the Green Mountains of Vermont. Like good old Killington would be, right in there. If you were to look at maybe what this would have looked like at the time, Indonesia is a really good example of this. It actually faces a similar direction, and it was down near the equator. So you would see mountains like this arc of Indonesia. This is Mount Ogunquit in Bali, Indonesia. A very active volcano, almost 10,000 feet high. There's another one back here. People actually live in this one, and you can see the chain of them right here, and they're all fairly evenly spaced because when you have diapirs coming up under these island arcs, they have a tendency to find weakened areas, and then the conduits have a tendency to be fairly evenly spaced out. I guess it's just the way the plumes decide to come up through the crust. For one reason or another, they must coagulate into some sort of a pattern volume, and then they start to make their way. And the Cascades do the same thing. There's like somewhat of a pattern to the distance that they're separated. So big, giant, deep trench out here. All sorts of terrible things going on. We've seen that from the earthquakes in this area that have occurred. Lots of volcanic activity here. I'm afraid that I may have had that. I think the south side is this. This is over here. Yeah, judging by the coastline here, this is the inland seaside that faces north, and this would be the southern side of Indonesia. So big trench over here. This is the Indian Ocean, and then you have, like, I think it's a Thai. Get the name of the sea that's behind it, escapes me right now. But anyway, calm water, very, very rough water, lots of swell, big giant trench, subduction going under, and this is where the plate is melting. The oceanic plate is melting and sending up the diapirs to fuel the volcanoes. Another idea of what you might have seen, you would see the waves of the Iapetus Ocean, nice blue ocean, beautiful waves, probably great surfing. What you would not see is any grasses at this particular time. They had not developed yet, but they were not far off. It is during the late Ordovician that seeds, or not seeds, but things begin to creep out and start to green the landscape. So, but this is what you'd see for an ocean for sure. Um, Vermont mountains. This is sort of what's left over of the Taconic orogeny. I believe this is the Camel's Hump. It's a 4,000 footer. You've got a very, very high grade gneiss, I believe the top of this is. Could be a granite. It escapes me. But in either way, it could be a granite that has now been metamorphosed into a gneiss, but or gneiss rather, depending how you want to pronounce it. In any case, it's very resistant to erosion. It's been scraped from glacial activity, and this is your typical what's left of the Taconic mountains that are about 460 million years old. Yeah, these are much higher. Yes. So here is the looking, I guess, at this side from here, looking at this the hump, and judging from this, looks granitic to me. It almost looks like it's exfoliating a little bit here. Could have been a granite that got compressed slightly higher. I'm not 100%, but anyways, it's a nice hard resistant knob and just enough above tree line to give you a spectacular view. Ordovician landscape here. So this is when it started to green. This is the very, very beginning of like plants trying to get their game going on. I'm not 100%. I think it's either algae, bacteria, or something along those lines that were able to start making that jump. And I don't even want to say that. So we're going to admit that because I would have to stop and look and find out exactly what it was that made the leap for plants to begin to colonize the terrestrial areas. But obviously something related to water, because everything else came from water, and we did have some sort of aquatic life, that plant life underwater, I believe. So anyway, this is the Silurian period. Now this is the next period after the Ordovician, and again a time of lots of activity in the western Iapetus Ocean, offshore here of Laurentia. We are now going to acquire some serious New England terrain and terrain of Newfoundland, Nova Scotia, and England and Scotland, and what have you, in the form of the Ganderia terrains. And the Ganderia terrains are like a mishmash of volcanic terrains, arcs, and a little bit of continental crust here and there. And we believe that originated in the northern part of South America, on the other side of the Iapetus Ocean, and a rift opened up over there, and when it did, it pulled off a piece of Gondwana, and in this case, it was a piece of northern Amazonia, and maybe some parts of Africa. Hard to say, but the same thing happened to Avalonia, right? A little bit east of that, where pieces of that got ripped off and dragged over across the Iapetus Ocean. So, an interesting time. The Silurian period will close various seas that were offshore of the Iapetus Ocean as it's beginning to close, and Avalonia begins to approach. So we probably had island arcs after island arcs and various terrains as they eventually made their way over and began to accrete onto the the south coast, well, right now the east coast of Laurentia, and it probably, uh, we use the model just north of Australia now, where the Pacific plate is sort of running into the northern part of Africa, where Indonesia is and Thailand and all those places. And if you were to take the northern tip of Africa, or the northern part of it's subducting one way, part of it's subducting another. There's a lot of little seas, there's a lot of little island arcs, there's all sorts of stuff. And that's probably a lot what the terrain coming into the embayment of New England looked like. Just a bunch of bays and seas and island arcs that just ended up getting sandwiched and crushed and crunched and shortened that made up the guts of New England. So, and that's kind of what's going on right here. Avalonia has also now made its way across, and it is on its way to make an impact with the uh, east coast of Laurentia. So here is the Silurian, 430 million years ago. Here we are. We have the Taconic, the island arc that is hit, and this has been built, and we have a nice big mountain range over here. Sea level has a tendency to have dropped. We're seeing some draining of the interior seaways. We have some subduction over here going on, and this area over here is going to come to make its way east and begin to accrete onto the west coast of Laurentia. And then we have more island arcs and what have you on their way over from the eastern side of the Iapetus Ocean. Silurian period about 420. These pieces of terrain are now beginning to impact northern Laurentia. We have more pieces down here on their way over here. You've got some offshore rifting going on and dragging pieces on over this way to eventually accrete onto the east coast and add real estate to eastern Laurentia. We also have the arc over here that is now making its way over to the western coast of Laurentia, and you can see that sea level again is still flooding somewhat, but not as much as it was in the Ordovician. This is the Silurian tectonic and paleogeographic map. 425 million years ago. We have gone through the Taconic orogeny now. We have exotic crust and the representation of the Ganderia terrain. Here is the Ganderia terrain. It is subducting, is being pulled off this way, but there's also subduction going down off the west coast, the east coast of Laurentia, and so you actually have the Iapetus Ocean and chunks of it closing almost simultaneously on both sides. And then eventually, this reef over here, this rip will end up stopping, and this will continue to be dragged over, and eventually the Ganderia and Avalonia terrain, which is represented by these two pieces, will form the Acadian orogeny, and then eventually Africa will close up what's left of the Iapetus Ocean. But in this case, we call it the Ray Ocean. This is the Iapetus Propter. This is the Rheic. And once this closes, represented by this is gone. Just the Rheic will be left. And then Africa will eventually come over and slam into the east coast of Laurentia. The sediments, believe it or not, of the marginal way are probably represented by forming somewhere in here. You've got the Ganderia terrain as well as the Avalonia terrain, and these two end up crunching these sediments. And these are the Kittery Formation sediments, and that is where the marginal way is. Over here, this is the geographical terrains. You've got the trench right here. You have open ocean. You have the mountain range of the Taconic Mountains. You have another trench up here. You have the Caledonian Mountains. You have volcanic epicenters here. You have basins forming from the erosion of all these sediments coming off. So you've got, I'm not sure, the Michigan Basin right there. This is called the Wilstein Basin. I'm not sure. But in any case, when you have lots of sediments coming off, they need to go somewhere. And if you form enough in one area, they'll begin to depress the crust, and you'll start to get basins forming. I guess this is a very important economic basin for resources. And then you have deep marine sediments here because there is a trench here associated with the Ouachita Marathon trough. and these will end up becoming the Ozarks. So as I've mentioned a few times, and I'm sorry about the blurriness, this is a very difficult sketch for me to make. It did not come out as well as I wanted, but the gist of it is you have Laurentia here, you have Africa here, um, and in between you have a seaway here and a seaway here and various island arcs. I mean, this also could be Avalonia. I don't think it is, but in any case, you have an Iapetus ocean here, and you have the western Iapetus here. And what happens is this arc here gets dragged across and closes this part of it right here, represented by this. And then everything just more or less ends up filling in here. Slab breaks off, and then subduction from this side begins to go this way. After this is crushed into here, and then this ends up coming being pulled this ends up being pulled this way, and as it does, it slams into this is Avalonia, into Avalonia, and thrusts all these sediments that were down here up onto it. And so you have deformation here, thrust faults, all of these are being thrust up onto the side here. And then you have the western Iapetus ocean here, and this will eventually continue to go, and these two will end up closing, and this will end up being over here, and all of this will be all crunched up. So this gets dragged into here, subduction stops off this, the slab melts, comes up through here, producing this right here. Subduction on this side begins over here and begins to close this area here, and then all of these sediments get thrust up here, and then subduction continues to go and drags all of this into here, and everything becomes one big giant mess. So that's the subduction reversal. Very complicated, but it started going east, and then it began to go west, and then once it continued to go west, it continued further than that to close everything in between. I hope I explained that. And the sediments that are in this area right here are more or less associated with these, and these are marginal wave sediments. But we don't actually close the western part of it until the whole thing gets shut. So this is basically happening, somewhat offshore from present-day Maine, and then this will slowly close this way. But you can look at it both. The arrow is basically saying that everything's being dragged together. So this is going in relation to this. This is coming this way, and this is going to this way in relation to this. It's just this whole thing is going to close, and everything in here is going to get thrust up onto over here, and then this will also be right here. Silurian landscape, very simple plants, swampy, still somewhat warm. You'd have volcanic terrain around here for sure, from all the island arcs and the subduction zones going on, and this is probably what you'd see. Those old guys are right there. Now, by late Silurian, the mountains have gotten a lot bigger. There's a lot more action happening, and the mountains are really beginning to push. We also start to have some more diversity into the plant terrain. So different things are beginning to happen. It's not just simple simple basic plants. Things are actually beginning to get a little bit more diversified. So later on the Silurian, you have more mountain building. Mountain building continues. Plants begin to diversify slightly more. And of course, the mountains continue to grow along the east coast, and they start to reach heights where they get snow-capped, and they start to look like a very large mountain range. The Devonian period. The Devonian period is the time that New England experiences it all. The Avalonia closes the eastern part of the Atlantic Ocean, the Iapetus Ocean, and it builds the majority of all the mountains we see from Scotland down to about New York. And it is the guts of New England, it is the guts of Nova Scotia, it is the guts of Labrador, it is the guts of eastern Quebec, and it is at this point when this microcontinent of Avalonia and pieces of Ganderia smash and close the ocean, that we get our mountains that in New England that are probably in the order of 20,000 plus feet high. And this begins to really come into fruition in the early Devonian about 390 million years ago. Here we are, giant trench going now under Laurentia. Africa not far behind. Avalonia has now slammed into this, and we have a massive mountain range beginning to build. Here's the Devonian period. These are the pieces of the microcontinents. There's Africa right here, and you can see we have a gigantic mountain range building right here. Ganderia terrains, Avalonia. The Caledonian orogeny has occurred, and it has produced a Himalayan-sized mountain range with Baltica right here. Around 385 million years ago, here is the closing of the the western part of the Iapetus, with a Rheic right here. The Rheic will be behind it. Avalonia is here, and we are smack dab now in a microcontinent, continent-sized mountain range that is well into the size of the Alps, Alps to Andes-size range. Not quite Himalaya size yet. That will come in the later Devonian. And now in the later Devonian, we have the subcontinents of Avalonia now collided. Ganderia has collided, the arcs of it, and this is a Himalayan-sized mountain range, probably in the order, roughly the same size that you would see the Himalayas today. Covers almost about the same area. It's whether or not it's reached the zenith of its height is unsure, but this is without a doubt a 20,000 foot plus mountain range. And here's Africa right here, and here's the Rheic Ocean on its way to close. Devonian period tectonic paleogeography. We are now down here. Well, we were here. Ganderia and Avalonia have now sutured. The eastern Iapetus is closed. This is the Rheic. The Rheic is now closing right here, and Africa is on its way, and we are about to have a continent-to-continental collision that will produce the final touch on the mountains and of the Appalachians, and pushing them into some of the highest mountains on the planet has ever seen. Acadian orogeny now. This would be on the timeline. We went through our Taconic. We went through the accumulation or the accretion of Ganderia, followed by Avalonia. That was explained. The Iapetus Ocean is now closing. At least the western part of it has now closed. And then the Rheic is what's left behind as Africa approaches. In New England, we do have we have a time of a strike slip fault that forms, and it goes right up through Nova Scotia, down through eastern part of Maine, goes right offshore, and then comes back onshore right at the tip of northeastern Mass, and goes through it now at Rhode Island. And that is called the Norumbega Fault, and it is probably on the order of the same size as what the San Andreas Fault is today. And that is represented by the strike slip motion as Avalonia and the island arc behind it, which does not show up in New England, but however does show up in Nova Scotia, far east of Nova Scotia, and in Europe. As they kind of hit obliquely and slid down the actual coastline as they hit. They kind of came in at an angle, hit, and then wrapped down the side of it, and that is represented by this sort of just kind of like what Baja California is doing today, and you have a stripe slip motion right there. And it isn't until Africa finally comes behind and closes the Iapetus or the eastern part of it that we will finish off with the Rheic Ocean being closed. And I am going to stop here because this is going to be all about the Acadian orogeny, and I hope everybody has a good day, and thank you for listening.